This ShowMe addresses the all-important topic in pre-algebra and algebra courses of the order of operations. This is a very important code that mathematicians follow and impart to their students so that all of us can understand what is intended when we write an expression involving numerals and variables in terms of how it is to be evaluated. We all agree on these conventions so that we can express to each other across language barriers and across the barriers of other kinds of communication exact meanings that are mathematical in nature. The show is going to be in two parts. I'm going to give a quick overview of how the order of operations is supposed to work, and then I'll give you 11 examples. And hopefully, between the two, you'll get the idea how to use this idea to be successful in evaluating your expressions. Grouped operations are operations that are held together and set aside to be done before other things using various kinds of symbols. The most common symbol that we see for this is the set of parentheses. Because that we often nest grouped operations, that is, we put a grouping symbol inside another set of grouping symbols, we have a series of operational symbols that are very similar to parentheses and have exactly the same meaning. We have parentheses, we have brackets, and we have braces. And they all mean the same thing in the context of a calculation. We have several other ways to group operations. They can be grouped inside absolute value symbols, which indicate not only that the operation inside is to be done first, but then indicate that the very next thing that should be done with the result is that we should calculate the absolute value. Other grouping symbols, one of the most important other grouping symbols is the division bar. The division bar is unique in that it doesn't tell you what to do first, but rather what to do last. Effectively, the division bar puts the items on the top and the bottom into their own set of parentheses, although we don't write those parentheses. As a result, what the division bar actually tells us is, do the division last. Do the operations in the numerator and the denominator first. One last example of grouped operations, radicals and exponents. If there are operations happening inside a radical sign, those have to be done before the radical can be performed. And if there are operations for whatever reason being done, say, in an exponent, those have to be done before the exponent can be done. Again, about nesting. We often put grouping symbols inside other grouping symbols. For instance, if we have an expression to be evaluated before we can evaluate what is inside parentheses, we put it inside brackets or braces to differentiate the symbols. Whatever is innermost must be done first, then the rest of the calculation may proceed as indicated by the order. So it's very important that we understand what nesting means. It means that we work effectively from the inside out. The second level of priority in the order of operations is powers. Powers include any expression that involve exponents or radicals, which are another kind of exponent in effect. So it's very important to understand the next thing we would do after we get rid of all of the parentheticals that we can deal with up to that point. The next priority falls to powers. After powers, the next priority is multiplication. Now here we have to recall that multiplication covers more than just one number times another. Division can be rewritten as a kind of multiplication. In fact, the definition of division is that when we take one number and divide it by the other, we are effectively multiplying the first number, the dividend, by the reciprocal of the second number, or the divisor. So when I say multiplication, I am also speaking of division, considering them as one operation, not two. The last area then is addition, and like multiplication, addition means more than just one number plus another. Subtraction can be redefined as addition. If we take one number and subtract it from another, we are actually adding the first number, the opposite of the first number, to the second number. So if you have 7 minus 5, what you've really got is 7 plus negative 5. Therefore, subtraction also falls under the mantle of addition. Now, many people may be wondering where the popular acronym for the order of operations has gone in my demonstration. Well, we're going to get to it. I want to point out that GPMA really doesn't give us a nice, easily memorable sentence. So we have chosen to use a different mnemonic. Grouped operations are most commonly represented by parentheses, as they are by far the most common grouping symbol. Powers are represented by exponents. Whenever we see an exponent, we know that we are dealing with powers. As I said, multiplication and division go together. Now that they are expressed as two operations using the abbreviation M and D, it's important to point out that when we work on multiplication and division, we simply go from left to right. Since, as far as I'm concerned, and as far as most mathematicians are concerned, division is simply another kind of multiplication. So we simply work from left to right when both operations are present. In the same way, addition and subtraction are to be done from left to right. Here's the popular mnemonic. Please, excuse, my dear, Aunt Sally. We don't know if Aunt Sally has said something untoward, perhaps misunderstood someone because she's a little hard of hearing, or if she just forgot to put on deodorant that day. In any case, she needs to be excused. This is the sentence that we use to remember the order of operations, and I'll use it in all of my examples. And away we go. In this example, there are no grouping symbols. There's an exponent. We have 3 squared. 3 to the second power is 9. Next up, we have multiplication and division. The only multiplication left to do now is negative 8 times 2, which is negative 16. Finally, then, add and subtract from left to right. 25 minus 16 is 9, and 9 plus 9 is 18. The original expression reduces, or simplifies, to 18. In this example, we do not have grouping symbols. Yes, we see parentheses, but here they are not being used to group operations, but simply to separate two known numbers for the purpose of multiplying them. There are no grouping symbols. There is an exponent. 2 cubed is 8. We have multiplication and division. We work from left to right. 3 times 7 is 21. 8 divided by 4 is 2. And 21 minus 2 is 19. In this example, we do have grouping symbols. We'll work each of them separately. 13 minus 7 is 6. 8 minus 5 is 3. All the grouping symbols are fine. There are no exponents. We have only multiplication and division left. Working from left to right, 15 times 6 is 90, and 90 divided by 3 is 30. Here we have two sets of grouping symbols again to deal with. First, 5 plus 3 is 8. In our second set of grouping symbols, we have two operations to be done. Which should be done first? Well, exponents or powers should be done before subtraction. So first we have 5 squared, which is 25. And then 25 minus 3 is 22. Now we have division and addition. Division and addition are to be done first. Division is to be done first. 8 divided by 2 is 4. And 4 plus 22 is 26. In this example, we have two sets of grouped operations. First, we have 9 minus 7, which is 2. And then 13 divided by 2, which is 6.5. Then we have division and addition. There are no exponents. Division first, 8 divided by 2 is 4. And then 4 plus 6.5 is 10.5. Here I want to do two examples side by side to give you a contrast as to how things work. On the left, we have a grouping symbol and then a power. We do what's inside the parentheses first. 15 times 12 is 180, and 180 squared is 32,400. First we did the parentheses and then the exponent. In the second example, we have 12 squared. That has to be done first. We have 15 times 144. And then 15 times 144 is 2,160. It's important to note the distinction. It matters what you do first. If you happen to do the multiplication first on the second example, you'll get the answer from the first example, which is incorrect. So do be very careful to follow the order of operations. Whoever wrote the expression for you to evaluate had an intention for what you would get from the experience. Here we have an example of nesting. The parentheses are nested inside the brackets. What is in the parentheses must be done first, because we work from the inside out. So 13 minus 7 is 6. Now, inside the brackets, the exponent has priority over the division. 6 squared is 36. Now, inside the brackets, we work first. 36 divided by 3 is 12. And 2 times 12 is 24. Notice that when we have nested grouping symbols, there really is no way to work straight down the order of operations. No way to work through that sentence about poor Aunt Sally, because the order of operations is hijacked completely by the grouping symbols. And it's important to understand why we do that. Sometimes it's important that we have an addition that should be done before a multiplication. Well, we wouldn't normally do that. How do we indicate that it has to happen that way? The parentheses. So it's very, very important that you understand grouping symbols are used to make sure that what we're actually doing in our calculations matches the situation we're trying to model. It matches the correspondence that we're trying to build between a real problem and the numbers that we're working with. Here's another example of nesting. Again, what's inside the parentheses must be done first. And the first thing that has to be done inside the parentheses is 2 squared, which is 4. Now inside the parentheses we have 4 plus 1, which is 5. Now we're working inside the brackets. And inside the brackets we have two operations, addition and multiplication. Multiplication is to be done first. 3 times 5 is 15. Now the brackets have to be done first. 4 plus 15 is 19. And then finally 5 times 19 is 95. Notice once again the importance of the parentheses in making sure that certain things get done in an order that is unusual based on the last part of our order of operations rules. And that happens because out there in the real world situations do arise where numbers have to be added and subtracted before they can be multiplied or divided. Here yet another example of nesting. This time 16 minus 13 has to be done first. 16 minus 13 is 3. Now inside the parentheses we have subtraction and multiplication. Multiplication has to be done first. 5 times 3 is 15. Now 18 minus 15 has to be done first. That's 3. Now we have addition and multiplication. Multiplication first. 3 times 3 is 9. And 12 plus 9 is 21. In this problem, I suppose we could point out that down to this step, we're fulfilling our grouping. We don't have any exponents to deal with. Then we did multiplication, and then we did addition. So a rare case where nesting doesn't completely upset the apple cart of the order of operations. And now for the last of my examples. Here again we have nested grouping symbols. We start with 2 plus 1, which is 3. Now inside the brackets we have exponents. We have an exponent and we have subtraction. The exponent should be done first. 3 cubed is 27. Then the bracket, 27 minus 3 is 24. And 5 plus 24 is 29. I hope the examples help you. Stating out all the rules and talking about all the possibilities and exceptions really doesn't do the topic justice. It's something that really has to be experienced, a lot like language. And it's fair to say that the order of operations is fundamentally the grammar of mathematics, particularly numerical mathematics. It is very important to know the order in which we all intend the calculations that we write to be done.